Torque is the rotational equivalent to force. If a force is a push or a pull, then a torque can be considered as a twist or a turn. Each force can cause a torque, and later in the course I'll describe net torque. For now, we'll focus on finding the magnitude of one individual torque at a time. Torque is often written using the Greek letter tau, spelled T-A-U, and has units of Newton meters or foot-pounds. Torque is actually a vector, even in 2D, which means that it has magnitude and direction. I'll focus on calculating the magnitude first and describe the direction separately in a later video. For any force F, the magnitude of torque can be calculated as Rf sine theta about a pivot point P. This is one of the strange things about torque. It must be defined about a pivot point, sometimes called a reference point. R, then, is a position vector from the pivot point to the force, and to calculate torque, I simply multiply the magnitude of R by the magnitude of F and sine of the angle between R and F, which I've shown here in green. If you recall from working with vectors, we can show magnitude by removing the vector arrow, which gives simpler notation. Torque is equal to Rf sine theta. In this example, there are two forces, and I would need to calculate the torque for each one. Tau1 is R1 F1 sine theta 1, and Tau2 is R2 F2 sine theta 2. Students often ask which angle they should use. For example, when finding Tau2, should they use theta 2 or theta 2 prime on the other side here? It turns out that it doesn't matter because theta 2 plus theta 2 prime is equal to 180 degrees, which means that theta 2 is equal to 180 minus theta 2 prime. And there's a trig identity which states that sine of theta is equal to sine of 180 minus theta. This is great. You don't have to worry about which angle to use. Just use whichever one is easier to find on your diagram. Oh yeah, you'll need a diagram. Preferably a large one because it can be very difficult to find angles on those itty-bitty diagrams that so many students draw. My only suggestion about the angle is to choose an angle between 0 and 180 degrees, or 0 and pi radians, because the focus here is on calculating the magnitude of torque, and choosing an angle between 0 and 180 degrees gives a positive magnitude. Although torque is a vector, as I mentioned in the beginning, don't worry about the direction yet. For now, just focus on the magnitude. In the next video, let's look at some examples.